Hey, College Algebra. So in today's video, we're going to talk about some matrix operations. So before we've used matrices to solve system of equations, now we're going to do some algebra with matrices. And this is what we're going to do. We're going to look at addition and multiplication. And before I get started with all that, I want to talk about how to describe the dimensions of a matrix. So here we have a 1 by 2 matrix where 1 describes our rows, and 2 describes the number of columns. And so here, in this one guy right here, we have 2 rows and 1 column. And this guy we have, the bigger one, we have 3 rows and 3 columns. So it's a 3 by 3 matrix. Okay, so let's first start off with matrix addition. And now, how this works is when you add 2 matrices, you look at your first spot, you look at your second. Now those 2 combined into the first spot of your matrix. Now you look at B here and F here, and they'll add right there. Now you see how they stay in the same spots. Okay, and we got C and G. They'll add in that new spot. The same goes for D and H. Now subtraction is the same thing, but instead of adding, all we're doing is subtracting, as you guys can see. Same idea. Okay. Now I also want to talk about scalar multiplication. And scalar multiplication is where we multiply any matrix by some constant number. And so here this S, all it's going to do is be multiplied by every single one of those guys. So our final outcome is this matrix over here to the right. Notice how all the A, B, C's, and D's stay in the same position. Okay, now let's do the example with scalar multiplication and addition. Now I chose this one because I wanted to show how scalar multiples can distribute to both matrices. So here we can rewrite this one right away and say that negative 1/2. And now just a reminder, what I said is that this negative 1/2 is going to distribute to our first and second matrix. And then honestly, just subtract. Actually, you know what? I want to leave that as addition because we're going to multiply that negative 1/2 through. Okay, so now all we have to do is multiply negative 1/2 into both our matrices. So when we do that, we'll end up getting negative 1/2 for the first guy, and negative 1 for this guy, and then negative 2. And now we do it for the second matrix. Okay, cool. So we got our 2 matrices. All we have to do now is add them together. So remember, we combined each section, or each element of the matrix. So here, our negative 1/2 is combined with our negative 2. So I have negative 1/2 minus 2. And then we'll have negative 1 plus 1, looking at these 2 guys. Then we'll have negative 3/2 minus 3/2. sorry, plus. And then -2 minus 1/2. Okay, now we just add those guys together. We should get a final matrix to be negative 5/2, 0, 0, and then negative 5/2. Okay, so we do that. Now I wanted to talk about when we can't actually add two different matrices. Now this guy right here, the skinny guy, this is actually called a vector. This would be more specific, a column vector. It's just a 2x1 matrix. Okay. Now we can't add these because if we look at 3 and 5, these guys have nowhere to add to over here. There's nothing we can do. So yeah, nothing that we can add, and so therefore we can't add these two matrices. Okay, now let's look at something a little bit more complicated. Now matrix multiplication is going to be a little bit trickier. And just a general way to define it, it's going to be our row times our columns. And so here, our A is going to be multiplied by our E, and then we're going to add it to B times G. So that's what we'll end up getting. Now we move on to our second column of this matrix B, and now we're going to multiply A times F and add that to B times H, just what we've done here. Okay, so now that you've gone through all the columns in our second matrix, we can go to the second row of our column, or of our first matrix. So anyways, now we'll multiply C, let's use a different color, multiply C by E, and then D by G. C times E plus D times G. Okay, now we move on to our second column of our second matrix, and we'll have C times F plus D times H. That's where we get this guy in a nice colorful matrix. Okay, but now let's look at the opposite. What if we're looking at B times A? Now I want you guys to pause the video and try to figure this out on your own. It's going to be great practice. Anyways, I'll pause it and come up with the solution. Okay, so this is what I ended up getting. Now, the steps I took to do this is first, multiply first row by first column of our second matrix, or matrix B. And then we multiply our first row again, but now by the second column of matrix A. I said that second one was matrix B earlier. I meant to say that was matrix A, since now we flip-flopped them. Okay, so now, so you can see, we have first one here, red. See one there. Okay, but now we need to look at our second row. So we're going to multiply our second row by our first column. So we'll get G times A, G times A, plus H times C. Okay, now last one, multiply our second row by our second column, and that's what we'll get. Okay, so let's look at some examples of these, because these can be a little tricky. Let's multiply this 2 by 2 matrix. Now remember, we need to multiply our first row by our first column to start off with. So let's go ahead and make our matrix here. And so we'll get 1 times 4 plus 2 times -3. Okay, what I did here is 1 times 4 plus 2 times 3. All right, now we got to figure out our next spot. To do that, we look at our first column again, our first row, multiplied by our second row for second matrix. All right, so now when we do that, we'll end up getting 1 times negative 2 plus 2 times 1. I'm going to go ahead, close this matrix. All right, so now we've multiplied our first column, our first row twice. Now we need to move on to our second row. So our second row is going to be multiplied by our first column of our second matrix. And so we'll have 3 times 4 plus 4 times negative 3. Okay. Now let's look at our last one, row 2. Multiply that by our second column. We'll get 3 times negative 2 plus 4 times 1. All right, so the only thing we have to do now is combine everything. Simplify, if you may. So up here we'll get negative 2. And up here we'll get 0. And then here we will get 0 also. And here we'll also get negative 2. Okay, so that'll be our final answer. Okay, but let's look at some matrices that aren't 2 by 2s or squares. Let's look at some vectors. Okay, now to do this, multiply our first row by our first column, right? It's just the same thing. Now this one only has one row. And this one only has one column. And so we should end up getting only one solution, right? So let's go ahead and try this. So this is going to be equal to. This is going to be 1 times 1 plus 2 times 2, right? So first we start with this 1 plus 1, or 1 times 1. I could have 2 times 2. Now, 3 times 3. Okay. Now there's nothing else I can do. I can't move over to another row in the first one, and I can't move over to another column in the second one. So that's our final solution, other than the fact that we just need to simplify. And that's our answer. But now let's flip it. What if we multiplied them the opposite way? What do you guys think? You think we'll get the same answer or different answers? Well, let's figure this out. See here, we have 3 rows. So first thing we do is multiply our first row by our first column. Now when we do that, what we'll get is 1. Okay, but now we have multiple columns here, right? So here we have 3 columns. And here we have 3 rows. Okay. So that means we have to move on to our second column here, right? So now it's going to be our first row times our second column, which is 1 times 2. Okay. Now we'll have to multiply our first row again, but now by the third column. And here we'll just get 1 times 3. Okay, but now that we've multiplied by all the columns in our second vector, we can move on to our next row. So we'll multiply the second row by this column right here. And so we'll get 2 times 1. Then we move on to our second column. We'll get 2 times 2. And we move on to our third column. And we'll get 2 times 3. Okay. Hope you guys are starting to see the pattern here of what we're doing. Okay. Now we multiplied all 3 rows, our second row by all 3 columns. We can now move on to our third row. Okay. So we multiply our third row by first column. This is 3 times 1. We move on to our second column. 3 times 2. And then we'll eventually have 3 times 3. Okay. Now that's our final matrix. Now isn't that something, how different this multiplication was versus this one? Or we just got one solution here. In this other slide, we need to get one matrix with 9 different solutions. Okay, but anyways, I'm gonna erase that. Now we just have to simplify this matrix, so just be 1 times 3. This one, 2 times 1 is 2, 2 times 2 is 4, 6, 3, 6, 9. All right, and so that's our final answer. And one thing I want to conclude here is that we have seen that the order of multiplication of 2 matrices has an effect on the outcome. And if we look here, back to this original slide, we can clearly see that E times A plus F times C does not equal A times E plus B times G. Now I'll write it out down here. And now since we're saying that, we can say that our matrix is non-commutative. And commutative basically states that the order of which you add or multiply or whatever your operation is doesn't matter. So with addition, it won't matter because we can switch each matrix anyway, so we can move our A from the left to the right. Now I just wanted to make sure this is clear. A and B are matrices. Okay. Now when we multiply though, they will not equal the same thing when we switch them, right? So now when we move this A from left to the right, they will not equal the same thing. Kind of crazy knowing that, you know, we've done math knowing that order shouldn't matter with multiplication. You know, 2 times 3 equals 3 times 2. I don't know, crazy stuff. But anyways, posted some questions on the blog for you guys to answer. I hope this video was effective in teaching you guys how to do matrix operations.